Windesheim.
Okay.
Ja.
I see the recording has already started. I see Rec in my
Me too.
screens.
Just arrived.
So I guess the chair or the organizing part, how do you say that? The facilitator is already recording it for us. Okay, that's one less thing I have to worry about. Okay. In my instructions is already, it also says that I have to inform you to select full screen view before the session starts. There should be a view button, which looks like a square with 3 little dots in the lower right corner.
Yep.
And then it should work.
Marijn, I think you're saying something, but it seems you're muted. Good morning, everybody.
Sorry, I said hello, Karen.
Good morning.
Morning.
Good morning. Nice meeting you.
Nice to see you all. So, Otto, you will be the first presenter, right?
I will be, yes.
Yeah. You know how to share your screen?
I know.
Perfect.
We already did a short test round.
Perfect.
Everybody is should be set, I think.
Okay, great.
Just I'm missing one of the speakers still.
Yeah, we have. Sorry. 1, 2, 3 speakers now, right? But we need 5. Or do I miss somebody here on my screen?
Bram is
Bram?
presenting 2 papers.
Ah, okay. Indeed. Yeah. Now I see it.
So if we start, I think I will time you if you agree. Maybe it's best that I warn you 2 minutes before the end of the time slot, if that's agreeable to you. I can do that by typing in the comments, or I can shout, but maybe that's a bit disruptive to you. So is it okay if I just type it in the comment?
Yeah.
Yeah.
I think so. It's more discreet.
Yeah.
And if questions emerge from the audience, this platform works in such a way that only the speakers can talk. The audience can just type. So I guess it's best that we just phrase the questions to you, because maybe it's a bit complex to get audience in and out of the speaker box. So let's try it that way. Good morning, Simon.
Good morning.
Hello.
Good morning.
Welcome all. Now we're complete as speakers. Are you all set also, Simon? And did you have an opportunity to test your presentation or to see how the sharing works?
Well, of course, I've practiced my presentation. I don't know how the sharing works. So,
Okay.
but I think there's a button on the left side. There's a screen thing.
Yeah, there is a sort of a screen with an arrow in it.
Yeah, moving to the right. Yeah.
Yeah. Yeah, I think that's the best option. Okay. So we are 9:15. So I guess we should get started. See if there is already audience coming in. You can wait a little bit to see if there's some people coming in.
What might be strange in this situation is this, the name of the session is 3.2. However, when you see the last program, it almost seems to be a parallel session that should be numbered with a 2 in front instead of a 3.
Oh,
So I wonder if, some attendants are now entering. So that, but I was afraid that maybe another link exists for attendance, but that will not be the case.
Yeah.
Okay. Good luck to all.
Yeah. So I see people coming in. So I guess we should start the session.
indeed.
So welcome all, welcome audience, welcome speakers. I first give the floor to Mr. Otto Paans, who is a concept developer at Heusje Kopier.
Yes, thank you. I'll share my screen right away because we have a tight fit in this presentation. You should all see my screen now, full screen. Is that correct? Okay, I assume so. Good.
Yes, it is.
Good. Thank you. Thank you for introducing me and on the presentation of design potentials between empirical data and architectural imagination, which is indeed an exploration. I'm a urbanist and landscape architect by background, so I will make this presentation, from a design point of view, really. So I don't have a technical background. I know something about technology, of course, but my main expertise is somewhere else. So my perspective is unabashed and unashamed, design-based. The point of departure, and that's really a recurring problem in designing over the last 20, 30 years, is that information by itself and data does not generate your objectives. It does not generate the objectives how you should design spaces. A perfectly technologically optimized space could be completely unlivable, and a perfectly livable space might be very unsustainable and technologically non-optimized. That's the first point. Second point, I think it's important to, when we think about circularity, and that's speaking from a landscape architect point of view, that we don't stop at thinking on the level of components or buildings or neighborhoods, but I think we have to take the largest systems that we have into account, actually. And the largest systems, circular systems that we have, are the natural cycles of the environment. And smaller systems that we have are the urban systems that are built on it. So those are the two main starting points for me. If we visualize this, then we can postulate two theoretical extremes. One is the theoretical extreme of technological rationality, where we say we have technological solutions to real-world problems, and we start to optimize the built environment based on data and information, and we develop a kind of technical vision.
Otto, may I interrupt you? I think your slides are not moving. Is that your intention?
That is my intention.
Okay, perfect. Go ahead. Sorry.
So, okay, can you see this slide, the two theoretical extremes? I'm sorry, because you say moving, do you mean animated?
No, we still see your first slide with the title.
Only the first slide, okay.
Yes.
This is strange. I can try to share again. I'll stop sharing and share again. We'll see if the system works. Application window, share. And now you see point of departure, I suppose?
Yes. Now it's perfect.
When I move now, do you see the next?
Yes. Now it's fine.
Perfect.
Thank you.
Thank you. So we are here. So we have on one theoretical extreme, we have technical rationality, where you say I optimize spaces according to technical specifics. On the other hand, this is a pitfall of designers over the world. It's aesthetic sensibility that takes pride of place, and that sometimes result in very unsustainable solutions that look nice nonetheless. I think there are many positions in between those extremes, and one I'd like in particular, and on which I present, is a kind of context-driven approach, where we make the interventions that we impose on the environment talk to the specifics of the environment itself. So that context-driven approach is a kind of mediation. So I line out very shortly a process of 7 steps, and then discuss how we worked with this on a project in Germany. The first 3 steps are generic. So when you talk about achieving urban sustainability of any kind as a designer, what would you do? What would you start with? And I think map some trends and phenomena, not to be comprehensive or encyclopedic, but simply to get a feeling for the field. So, for instance, we know that due to climate change, the climate gets warmer, there is an increased demand for air conditioning. We also know that much of the electricity that we generate, that it's produced by burning fossil fuels. And then, in turn, you have resource depletion and the emission of greenhouse gases. With this in mind, you could review sustainability goals that have been set and say, well, this is an undesirable situation. We'd like to change that. And that results in objectives. For instance, reducing energy demand or reducing the emission of greenhouse gases. With that in mind, you can move on to your context, to the real world situation you are designing. And first, what we did, we started with mapping recurrences in the built environment. Because the built environment, the way we produce it nowadays, it's quite regular. It's very module and modular based. So all buildings have doors, all buildings have windows, all buildings are connected to an infrastructure. Infrastructure is again made up of greenery, of parking places, of streets, of connections. So you can map the recurrences. Then in the next step, you analyze the features of your built environment in more detail. And actually in this phase, what you do is you have value judgments about what happens. Which features are desirable, which are undesirable from the point of view of your objectives. Then per theme, and you can thematize your content, you select a number of sources. And important is that you don't need to be comprehensive again or encyclopedic, but just get enough information for you to work with the problem. Not too much, not too little. And once you find there's not enough information for you, you start searching again. And then in the last step, you create a kind of spatial catalog of options that you can apply to any given context, but which are supported by data. So I'll show you a slide which I like to show always about urban sustainability. Once you start designing, it's a holistic science. You cannot just take one factor, isolate it completely, especially not in the built environment, optimize it, and then go on to the next one. Always, it's like this control board where you have a number of knobs or buttons, and once you turn one, then you turn the others as well. It's a kind of mixing panel, and that's what this kind of mapping. That's what we do in the first generic steps. What are the sustainability goals, and what are our objectives? The real world context in this case is Hellersdorf Süd in Berlin, and it's a typical Plattenbau settlement made from the 70s to the late 80s. Not performing very well in terms of sustainability, and very, very large scale, far larger than we have in the Netherlands actually. And what we did for this environment, we mapped the spatial properties and possibilities of this space, and we tried to make value judgments right away from the point of view of the street. That's important because that's a first-person perspective. Then we try to understand the spatial configurations we came across. So, for instance, here you see a flat roof that's exposed to the sun. That comes with the typology of the neighborhood. Then, once we understood this phenomenon on a neighborhood level, you can build a chain of consequences. A flat roof means full exposure. Concrete and steel structure means that the heat is trapped. It means that the spaces underneath get extremely warm. It means that people are going to install airco units. It means that the energy demand is going up. So you set up those causal chains, and you set up some sources that you use to understand the phenomenon. Once you understand this, you can develop a kind of set of strategies to deal with it on a neighborhood level. You could have your PV panels, but you would still have the heating problem. You could lift your PV panels by one floor, so you have the wind going underneath and the shading of the original roof. You could have green roofs, which, when applied to an urban scale, creates a microclimate effect. And so for every problem, you can have a range of high-level solutions that you can apply in a variety of situations. So the design problem is always open and networked and anarchic and underdetermined. So if your preferred point of view, if your point of view of optimization is not available, you just start everywhere. And this feels for many people very uncomfortable. I think for many designers, it feels quite natural to work on 3 topics at a time, actually. And once we had this catalog, we started to work on 3 scales. Neighborhood scale, where we picked out certain spots for refurbishment, interventions on an urban level or a block level, and then detailing again, where you end up at the street level, actually, where we started with the analysis. And I think what you got out were kind of integral plans, in which many technical solutions and strategies and also the requirements and the context itself co-evolved. And that's because you represent your findings immediately as an architectonic space, as a 3D space. And I think this is very important when thinking about the relation between technology and design. I think technological solutions that are abstract, that are not applied to a space, I think they are of limited value when you apply them just haphazardly. I think you have to apply them in a designing way so that you immediately see what their effects are. Not only their technological effects, but also the spatial and emotive and aesthetic effects. And I think once we zoom out, even one step bigger, you could imagine that you do this, for instance, on a larger scale. And I have taken one example here that I worked out a little bit further in the paper. You have the urban-rural zones in southern Limburg. Once you could plan for 30 years ahead, let's say for a transformation of these zones, and then you could actually map our problems as we have them currently. You could map and set objectives for a kind of new conception of how landscape and urban areas would relate. And I think especially in the notion of circularity, because the challenge with scaling up in this way and applying all the strategies I just presented on this scale would be to take the natural cycle of the environment, the largest circular system that we have, and then use that as a basis to completely topple the landscape versus urban relationship. And I think we could turn this relationship by 180 degrees and completely overturn the way we build cities. Of course, this is extremely compact and it's a kind of suggestion more than a worked out perspective. But I think nevertheless, with good design, it's completely possible. Thank you.
Thank you, Otto. As is programmed, we do all the presenters first and turn to the questions afterward. So you can already think about the questions that are entering into the chat. I'd like to give the floor to our next speaker, Felipe, Bucci Ancapi, who is a PhD student at Delft University. think your microphone is still off. I still don't hear you. I see your screen, but I still don't hear you. I'm sorry.
Somebody is mentioning in the chat that it might help to refresh the page to be unmuted. So maybe you can try that.
Yeah, he's exiting. Since we are waiting, should we go into the questions or we move on to
Yes,
to
we can do
switch?
that. No, I think we can do that.
Maybe we ask Bram to do his. Oh, there he is.
You hear me now?
Yeah, now I hear you. Okay.
Sorry for that. I'm going to share my screen right now.
Okay.
Yes.
And start with it. Yeah. Can you see it full screen?
Yes.
Yes.
You can
Thank you.
start.
Amazing. Okay, so just to start, in the program, the name was different. It was called like managing circular built environments, but along the way I had to change my research a bit. So it's now actually more or less about policy instruments for circular built environment implementation. I'm doing my PhD at TU Delft. My background is in political sciences, and I'm an urban environmental manager by Wageningen University. So what we know so far is that circular built environment has been posed as a possible solution for unsustainable pathways in the way we actually build and operate our cities. Circular built environment also has research has rapidly increased in the last 5 years, and that's something we can see just like by quickly look at the Scopus or Web of Knowledge. Some cities around the world and countries as well have started to envision their circular built environment transitions. Here, for example, we have three cities that already started with that: Leuven, Den Haag, and London. And as we know as well, the circular built environment is the result. It also implies a complex relational, multi-level system of resources, institutions, and entities that make it up. What like made me start with this research was these two quotes from Pomponi and Moncaster, and also from Munaro in 2020, is that the initiative themes around circular economy in the built environment normally demonstrate little interdisciplinarity underpinning the complexity of such transitions. And 4 years after Murano says, or 3 years after Murano says, well, even though research has increased and diversified, we still have a lot of challenges concerning governance and the management of circular built environment transitions themselves. So the aim of this research that is still going on, and a lot of changes are going to be introduced after this conference, is to provide a simple review of policy instruments for circular built environment implementation, trying to supplement this question of how to govern the city transition. So I come up with 3 questions. How many publications elaborate about policy concepts in general for circular built environment? What kind of policy instruments are mentioned in these publications? And what concepts are operationalized in the selected publications? I'm going to explain that later. So the method I use is systematic literature review. The PRISMA guidelines that are used in medical sciences to report cases about different kind of diseases, and this gives the opportunity to be transparent about the process of searching the keywords in different databases, and so someone can actually replicate it afterwards. What I did was to look in the Scopus and Web of Knowledge for circular economy and built environment to construct as keywords searching keywords, and then I group what I got in 4 different groups depending on whether or not they have the word polic, manage, govern, or plan in their title, abstracts, or keywords. From more than 1,200 articles, I ended up having just 44 that completed the selection criteria. And going straight to the results, so we can spend probably like 1 or 2 minutes discussing about this. How many publications actually elaborate about policy concepts for circular built environment? The number was 44, and that represents 7% of all the articles I found over this. Well, after duplications were removed, because I was consulting 2 databases. Just 29 were articles, 9 were book chapters, and 6 were reviews. The main journals that are normally talking about policy-related concepts are Clean Air Production, Sustainability, and the Journal of Resource Conservation and Recycling, which I think is not surprising. Most of us probably are aiming as well to, if we are researchers, to publish in actually this or a couple of other journals. And when I grouped the different publications I found into those containing the word polic in their title, abstracts, or keywords, you can see that just talking about policy, there's just 16. So actually, it's really good that you work with different keywords for your search. Otherwise, the number would have been really, really small, and that's how aggregating you have 44. Just to show a bit. In terms of keywords co-occurrence, I use this visualization tool, really good one, VOS Viewer, and you can see here that, well, of course, circular economy and the built environment are the most cited keywords among these 44 selected publications. But what's really interesting is, though I'm looking for policy-related concepts, those related concepts are not part of the keywords. So this tells us, and this is something I realized reading all these articles, is that normally policy-related concepts are part of either policy recommendations in the last part of the article, or as for the research topics, something that should be developed by someone else in the future. Answer the second question, what kind of policy instruments are mentioned? I followed Keyword 2002. It's a really generic classification of policy instruments for sustainable built environments. And I separated them, well, these are 5 different categories: regulatory instruments, economic, information instrument, voluntary instruments, and research and development. And I was looking for those explicitly mentioned and those implicitly mentioned. That means like those that are calling for, I don't know, the integration of a material passporting regulation, or something that said like we need to develop a database for materials used in construction. So they are slightly talking about the same thing, but some of them are explicit about the policy instrument they want to refer to, and other ones are more implicit. So you can find that there are norms, there are taxes being mentioned, guidelines as a way of information policy, sector-wide agreements. This is voluntary agreements within the sectors, and also some calls for public investment for research and technology for material recovery and use. This is not everything, but it was also interesting to see that while a lot of people are asking for material passport, there was just one mention of carbon tax. In this 44 publication. There was the case of a book by David Ness in 2020. Also, when I was trying to see what concepts are operationalized in these publications, I looked through all the method sections of these articles and publications. So I grouped or I looked for what they were actually talking about, and most of them talk actually about technological dimensions of the transition. And that's why they afterwards come up with these policy recommendations related to those technical solutions. So these are the findings. Great attention has been given to technical aspects, because I say, like urban mining, material flows, and material reuse. Meanwhile, publications with a strict focus on policy and policy instruments, for example, policy making, implementations were scarcely found. It can be argued that the thinking of policy instrument is influenced by the thinkers of technical solution. And this is, I think we can all agree that when we talk about the circular built environment, probably everyone in this room is related to construction, architecture, or design, but none of us is really into the policy making of these transitions. So that's just to say there is room for research, for the knowledge gathering, so to speak. As a conclusion, just 7% of results elaborate on policy-related topics. Policy mainly mentioned, as I said, as policy recommendations for the research directions. Well, compared to a more generic classification of policy instrument, we can see that there's a wide variety of categories, although technical dimensions is predominant among approach concepts and publications. And therefore, further research is required to analyze things like policy mixes for the transition in terms of policy coherence and transition itself. There are different frameworks that have been used nowadays, for example, for energy transition, as the case of transition management within sustainability transition research. And it would be nice, and it's actually something that I'm trying to do, to implement these ideas in the field of the circular built environment transition. So that's it. I hope I didn't pass the 10 minutes I had. And
not at all, very well timed. Thank
Thanks.
you. Okay, so as I mentioned, we turn to the questions afterwards. People still have some time to think about questions and type them in the chat. I suggest we move on to our third presenter, Bram Entrop, who is an associate professor at Saxion University of Applied Sciences in the Netherlands. Bram, I hope your microphone works.
I switched it on. Okay. And I also hope that you see my presentation. That should be on the screen now. I see some nodding, so let's get started. Well, what was the starting point for this paper? Well, that was the idea colleagues at the municipality of Apeldoorn within the City Loops project that I had when looking at their soil and sand depot. We were wondering if the soil and sand depot could operate as a proper example for other material loops in the construction industry. That was the starting point for this research project. And as you might be aware, soil and specifically sand are important resources. Magnussen and co-authors even speak of the management of soil as an important element of construction project. Soil and sand depots offer space, and in some cases even serious helping by matching supply and demand for soil by means of quality and quantity. So our main research question became here, how can the quest for a circular construction industry benefit from the experiences gained in facilitating a local soil and sand depot? Well, what's told in the literature then? Well, of course, it's explained what sand is officially all about. It's namely a soil particle between 0.05 and 2 millimeters in diameter. And, well, soil, that's a more abstract, because that's the unconsolidated material on the immediate surface of the earth that serves as a natural medium for the growth of land plants. There are, of course, also some other definitions, but more importantly, that we need to address also the quality of sand. And the quality is related to the functions that sand can have. And here you see some examples. Furthermore, it was found out that also some literature exists about the environmental impact this important resource for the construction industry has. Sand has, of course, just like rocks, quite high density. And so you can see that the impact regarding energy use, and therefore also the environmental impact when handling sand and rock, is quite high. So that were some elements of our literature study we conducted. What is then happening in real life? Let's have a glimpse of what's happening when we enter the field of practice. And strangely enough, in 2004, we found in the Netherlands that around 650,000 sites were contaminated. Later on, we could be slightly more positive about it, and we could reduce this number of sites. But it was quite astonishing, of course, that we experienced this problem. The Netherlands are a quite dense country, so the strain on sand supply is quite high. And we really needed to figure out what to do with these sites and what the actual status are. And we have more or less 3 main categories to address the quality of soil in place then. It could have the quality in line with the background value, which might be expected already from a historical point of view. Soil can have proper quality to function and operate in residential areas, or it could be, when it's contaminated slightly more, address an industrial function. And here are some parameters we will check the sand for to assess its quality. Furthermore, we mapped out for the whole of Netherlands, but here you can see an example of the municipality of Apeldoorn then, which was our case, where research was conducted about the quality of sand in place. So we mapped out quite well, also in other cities in the Netherlands, what is happening. And we were able to reduce those 650,000 sites to approximately 200,000 sites. Here you can see the specific situation in the municipality of Apeldoorn, namely that soil and sand site located in the northeastern part of Apeldoorn, quite close to the highway over there. And at this site, multiple spots can be found. So these are different, piles of sand and soil coming from different projects, and they will stay in place till after the actual quality has been assessed. So the project where the sand comes from, their first historical check will be taken place, and later on, when it's located, or when they do not expect it to be polluted, then it can be placed at the soil and sand site. And here an actual check will take place regarding those ingredients, all those contaminations I showed earlier in the table. The soil and sand site of the municipality of Apeldoorn is quite commonly used. And here you see some figures about how much soil is being transported at this site. You need to think of approximately 11,000 till 23,000 cubic meters of soil passes through this depot every year. Some batches are relatively small, as you can see on the right side in the right figure, and there are also quite large batches. For one project, for example, over 5,000 cubic meters of soil was transported. This results in many truckloads, because one truckload is approximately only 20 cubic meters of soil. The processes by which sand is coming in and is being transported, and the moment when you check for the quality of sand differs. Here you can see a scheme we developed by means of interviews, conducting interviews among different people, but most importantly, because they're quite small letters, the trajectory that's important for this soil and sand site is highlighted in red. So you can see here already in the project that operates as a donor for the sand, there a historical background is checked, and later on, around here, you can see that according to the AP 04 regulations, the actual sand quality is being checked before being transferred to a next project in line with the functional use that aligns with the quality of the sand, of course. Well, what does it mean furthermore? That although the quality of the sand was assessed relatively low on forehand, so when the sand was still in its donor location, after having checked the quality at the local depot, the quality could be improved only through assessment. So no handling was taking place, no purification processes took place, but our expectations was that the sand would be of a low quality. After being assessed, we could definitely say, well, no, it's from a much better quality than expected. This generates quite a profit for the municipality of Apeldoorn, but it's unfortunately quite speculative, of course. Well, regarding the challenges we had, we experienced that it was not easy to retrieve information about the resource flows coming in and out of this soil and sand site. So there's not always 24/7 a person at the site to check what sand comes in and how much sand is leaving. So when you would like to apply this method to also other material streams in the construction industry, of which you would like to close the loops, then we still have some developments to take place, because this way of working will not apply to those other material streams in the construction industry for sure. What's also important, considering also the results of the literature study, and the best way, of course, is to check if we can handle the sand directly on location. So the transporting is not necessary at all. Well, probably for the future, we need to think about a new kind of logistics system, because the current way of processing the sand is time-consuming, prone to errors, and costly, especially when you also want to apply it for other materials. And maybe in the field of automated sensors and digital infrastructure, automated tags applied to materials could help in designing better depots for other materials. What's positive about it? That the soil and sand depot is an important node in the logistics system, and for this material flow is helping really a lot in matching quantities and qualities of sand and soil. That was my first presentation in this session. Thank you for your attention.
Thank you very much, Bram. Well timed also.
Thank you. I will quickly move to my second presentation, I suppose.
Go ahead.
Okay. Let's close this one. Oh. Yes, it seems to work quite well. The second presentation is quite another topic, although still we're in the preparation stages of building projects. This is a project we conducted together with the municipality of Weijer, and we are the research group Sustainable Environment of Saxion, then of course where I'm an associate lecturer. And we wondered if we try to come to circular objects, circular buildings, why shouldn't we take care in already the preparation stages? When preparing a site, what thoughts are given to circularity, and maybe more general sustainability, and that first stage at all. So Afke, Lisanne and I wondered if the environmental impact of the stage before construction activities actually take place can be reduced. And we had the ambition to do not only research, but really to develop an instrument. An instrument for those who are involved then in that process of designing and executing site preparations, and to contribute to a circular economy. And just to prepare you for what's coming, we developed a kind of questionnaire, an automated questionnaire that assesses grades to the rate of circularity of that preparation process then. But first things first, which steps did we conduct? Of course, we started with the literature study. Then we were interviewing 9 professionals involved in preparing sites for construction activities. Furthermore, we started, of course, designing the instruments and gave thoughts on how to structure and gave appearance to the instrument. And we tested the instrument onto projects within that same municipality, namely the municipality of Oosterweijer here in the Netherlands. Based on 4 literature sources, we came to 10 stages in the process of preparing a site. And that are just conventional stages we distinguish. sustainability nor circularity was involved yet in this conventional way of preparing a site. Every individual stage considers multiple activities. Let me show you in detail, for example, here. The first stage is conducting site research, and it encompasses, among others, site research on ammunition dating from the Second World War, for example. When we continue, you can also see that in some cases soil improvement needs to be executed, and so we continue till the last stage, completing the site preparation process where employees and equipment is withdrawn. So quite many activities, and we wanted to give back with our instrument to those involved in preparing the sites then, that you can question the activities you conduct in every stage and with every activity conventionally planned. So we saw three main topics coming out of those interviews and the literature, namely materials, equipment, and personnel, or people. In Dutch is quite easily because you then speak of materiaal, materieel, mensen. But in English, unfortunately, we don't have that alliteration here available. So materials, equipment, and personnel. And we developed 64 questions accompanying with 28 answer models regarding materials. Regarding equipment, we came to 35 different questions, and personnel, probably we still need to improve our instrument on that, but currently we came to 16 questions and 7 different answer models. And of course, the most simple answer model is a yes or a no, but always it needs to be supplied with a kind of evidence on what is actually happening in the project. The name we gave to this instrument was a contraction of preparation circularity on site. In Dutch you would call it precisie. And here you see that the name we developed then, which is probably in English slightly harder to pronounce. We made use of an easily acceptable Excel format, and let's have a look in more detail about what is looking like then. Here you can see in the first column quite easily if you answered a particular question. Here you can see for 3 different categories. Here you can see examples from materials, but of course we also have that then for equipment and people. Here you can choose from a drop-down menu your answer, but additional questions and arguments need to be provided. In the end, the final column will give you a quick overview if you score sufficient on that specific topic, and we have a score related to that. And that score matches a quite common system, at least in the Netherlands, namely 1 for the worst situation possible and 10 for the most excellent situation. So the highest grade is a 10. 6 is what we call in the Netherlands sufficient. So this was the model, the instrument we developed. We applied it on 2 projects, namely Noorderkoeslag and Oostergaard. And these projects, here you can see in the left upper corner, you see 3 marks for Noorderkoeslag. Namely for materials, it was just sufficient, 6.4. And equipment and personnel, well, there are quite some improvements to be made there to regard the project as more circular than it currently is. And we currently still think that the 6.4 is slightly positively overestimated. So that it should be a lower mark than we now provided. The other project, Oostergaard, we were not able, because there was no contractor yet chosen, we were not able to select the equipment, to assess what equipment is going to be used and where the personnel comes from, etc. And other questions regarding personnel were not able yet to answer. But regarding materials, we came to a quite high rated mark of 8.1, which also not yet correct, we think. So more cases are necessary, and the gradation of questions and the impact of the questions and their answers still needs to be improved, to be honest. However, we're quite happy that this first version of the instrument is available, and that the users were positive about the questions that were laid down, because, well, for a contractor in these kinds of projects, of course, they want to start as quickly as possible, and they're not that fond of answering questions to assess sustainability and circularity issues and extra forms from the municipality. They're not that fond of those, but they are quite positive about the questions we laid down, so that was quite helpful for us to find out. We still need to improve the impact of the different scores on the questions, and we're looking forward to test more sites to improve this instrument. And that was my second presentation. Thank you for your attention.
Thank you very much, Bram. Again, well on time. So now I give the floor to the last presentation, a paper of multiple authors. I have Julian Loef, Maarten Stadhouders, and Simon Duindam, of which are present Simon Duindam and Maarten Stadhouders, I see. Who can I give the floor to?
You can give me the floor.
Okay, please, Simon.
I try to share the screen because I got a presentation. Could you see this presentation now?
Yes.
Okay. The three of us are working together in reuse materials, and in this project, material energy flows in the demolition stock of Parkstad. We also work together with other parties, like the Super Local Project and Humble Buildings and Zuid University. Our presentation, first of all, is about the scope of our project, the research we've done, the methodology we used, and then we show two Sankey's with material flow and energy flow. And at last, we like to say, maybe a lot even, on how to proceed from the research we've done. Reuse Materials is based in Heerlen. It's a company is making inventories of buildings, looking for all kinds of materials with high value to be reused. And that was an important starting point also for this research, because we've been doing that already for about 10 years. And especially the Parkstad and Heerlen environment and region is an important region to develop these research and scope, because since the closing of the mines, demographic change will lead to a lot of changes in the built environment. Population decline has been 20% since then, and even the aging of the public is also changing the needs for other buildings. So there's a lot of renovation. There's a lot of buildings that will need new destinations, and one of these destinations is a primary resource for new building materials. You could say it's demolition, but you can also say it's something to build something new. The forecast for the Parkstad region for the transformation of the built environment is that 10,000 houses and 150,000 square meters of retail and utility space have to be removed. This causes a significant flow of building components and materials. Thirdly, we've got 30,000 homes, and the Parkstad region has 250,000 people on the Dutch side. and is built together on the German side also because we've got the Aachen Parkstad region together, 800,000 people. On the Dutch side, the mines closed in 1975, the last one, and on the German side, it was 20 years later. So what we're developing now, and what we're seeing now on the Parkstad side, will also be relevant in the next years on the German side. The renovation of 30,000 homes to the level of almost energy neutral and the realization of 10,000 natural gas-free homes is also a challenge in this respect. So we got significant potentials for reusing, refurbishing, recycling building materials, and also discovering what is the energy impact of all these flows of materials. And when you concern energy impact, it's of course the situation that if you can reuse materials, you don't have to produce them, you don't have to produce new materials. So the embedded energy and the embedded carbon emissions in producing new materials is an important also economic factor to calculate the amount of materials, to calculate the value of the materials and how to deal with those values. And that's what we are doing also currently right now, and the rest of the presentation is about this issue. So we mapped out how many raw materials are released and how much CO2 emissions and energy can be saved if these raw materials are going to be reused or recycled. And that's a dynamic process because I've got a background in law and economics. Already 25 years ago, did my PhD in that field. And since I've been involved in reusing materials, but also using blockchain technology to register all these kinds of materials, to make them tradable, to connect them to other rights, this has come an important perspective of also the macroeconomic analysis. However, everything starts in this process by making an inventory of a building. And Reuse Materials has been using the CEDAX software system for doing so. And the CEDAX system will provide material passports to every material in a building, and as such gives every material an identity. Together with another company, Block Materials, we register those materials in the blockchain, which not only gives us an identity to the materials, but also gives us a verified identity, which means that inspection by the CEDAX system also gives access to tradable property rights on those materials in buildings, even if they are still in the building and not free on the floor or free somewhere else as part of the demolition process. 2 months ago, a report started that said, well, if you want to start circularity in the built environment, everything starts with registering those materials that are in the building. And if you don't do this registration, you don't know what the value is, you don't know how to do it, and you can't connect it to other possibilities. So CEDAX is a very important development and very important system in this. What did we do? The material flow potential from the building demolition stock has been put down in this Shanky. On the left side, you see the kind of buildings. On the middle side, you see the amount of materials. So we made an inventory of the left side to get the results on the middle side. And on the right side, you see the possibility of reusing those materials in a low grade or high grade or on a product level. You still see in the green flow that there is a huge amount of low grade recycling still left. And that's also a challenge to proceed for the future. However, if I make the same Shanky for the embedded energy, you could already see that some materials put in an energy perspective have a different flow. you still see that low-grade recycling is quite high, but not as high as in the material flow. But if you make the combination between the material flow, the embodied energy, and the CO2 emission rights, you could see that if I could materialize those energy and those embodied energy, embodied carbon emissions, I get a completely new perspective. You could see again that the real estate on the left side, how much real estate is involved in Parkstad. You could see if I made an inventory in building materials, how much building materials are there. So the question is, can I use those building materials in such a way that high-grade recycling is going up? And since we've been doing this already also for 8 years, we've discovered that a lot of real estate parties don't know the value of second-hand materials. We've also seen in the last 10 years that the value of second-hand building materials is quickly rising because of scarcity of materials. And thirdly, we see all kinds of possibilities of all kinds of developments to calculate the CO2 emissions in a real value and to connect it to the material value of the materials. So what we've been doing, and that's in the how to proceed, is can we create CO2 emission rights by reusing materials? Because the building industry is responsible, if you internalize also the logistics and the way buildings are built, for about 40% of CO2 emissions. However, if I reuse materials, then the CO2 emission rights, so the alternative costs of creating primary materials, is really is decreasing a lot. And by reusing materials, we create CO2 rights. The word right is very important because we connect the materials to the blockchain, and because blockchain gives us unchangeable information that can be tracked and traced all the time, a blockchain registration gives a material a property right. And once a property right is there and undisputed, also by verifying it by blockchain transactions, then we have the possibility to connect material rights to CO2 emission rights. In the current status and policies, it's not possible yet directly to create CO2 emission rights because the ETS system done by the European Union only provides CO2 rights given by governments. In the Netherlands, however, there's a second option now that's called the Nationale Koolstofmarkt, or the Dutch carbon market, that can recognize a process in which you can create CO2 rights, in which you can connect these CO2 rights to a value and to connect the rights and the material rights, for example, in a trading platform. The possibility of doing that also means, and also the possibility of using blockchain technology, means that we got an objective basis also for taxation. Connecting CO2 rights with property rights can also bring in the CO2 tax and combine those materials and giving that value to those materials, but a completely different effect of how should we reuse materials. In the current process, we are getting into a process with the Dutch carbon market in order to capitalize on saved CO2 and saved energy rights, to combine it with the possibility for the Parkstad region. And in the last few months, we've also seen that the prices of second-hand materials are rising that quickly that high-grade reusing materials is currently demanded by a lot of parties. We're making the connection also with the Gemmelot campus, Brightlands Gemmelot campus, in order to connect what we've made an inventory for with the circular hub, so that materials won't go under the ground, as for example for roads and buildings, for making roads, but we make direct connections with reusing concrete to a concrete factory, reusing bricks to a brick factory, and using all kinds of plastics and things like that to the Gemmelot campus, where they will be used as primary sources for the new products made on that site.
Simon, we need to interrupt you because we're running out of time.
Well,
can you conclude?
That was my last.
Perfect. Okay, thank you.
Okay, thank you all. So 5 very interesting presentations on a wide spectrum, I'd say. Maybe it's best to go back to the questions that were entered into the chat and give first some discussion about the first paper, Otto. If you agree, Karen?
Yes, sure.
Okay. So, Otto, I see you had a question you already addressed a little bit, but maybe we can discuss it further from Waldo Gouwe of the VUB.
Yeah.
How do you protect the set objectives during the following steps?
Yeah, this is an important one. Designers, they are routinely used, I think because the way they work, to change their requirements, to change their objectives, and that comes with part of the creative process. On the other hand, I think, first of all, when you start designing, especially large projects, you have to set your objectives beforehand and stick to them. Otherwise, you start to negotiate them, and negotiation means almost always that you lower them a little bit. I think there is one good case that you can make where you say, well, I lower my expectations and I lower my objectives and the things I want to achieve in one area, because that creates a trade-off in another area. So you gain something that's more valuable by lowering your expectation in another domain. I think that's an acceptable way, and I think that is the point where a design process actually can help. For us, it works very well if you somewhere in the middle of a process, when you have a reasonable grasp of content, whether it's about transformation or landscape plans, when you say, well, those are the developments and here are the trade-offs. Here we always try to visualize the conflicts between two competing interests, for instance, or competing policies, and say, well, we have now to choose one over the other. Each will have consequences, but once you know the consequences, you can choose how to deal with them and choose to compensate them, for instance. And I think that's really important. And I think the second thing that comes with that is, as a designer, you need to work interdisciplinary, because the last 30, 40 years, there has been an increasing pressure on designers to act like engineers, and we are not engineers. It's simply too much. There are very good engineers out there who know their profession better than we do, and it's important to work together with them, so that once you set goals, you can check your proposals, and you can have them check your proposals and see if you're on track. And I think that's tremendously important. And many, I think, people in the design profession, sometimes they have a bit, they get a bit cold feet when it comes to that. You know, it's all about the design vision, the artistic part, but that's only one part of it. And there is also the performative aspect. So that's what I would like to add.
Maybe one follow-up question on that, Otto. Is it not important when setting your goals or ambitions that you have your stakeholders involved in defining these ambitions to avoid coming back on these later on?
Yeah, that's normally we do. We work a lot for municipalities, so that's what we do early in the process, very early. It basically starts with 2-3 sessions. Like, what do you think is important? What are the main issues and what are the main goals? And it turns out, in my opinion, that people have they have a problem squaring what's committed to in policy documents with the situation on the ground. Be very high, let's say, high-minded and ambitious goals in policy documents. You say, well, how does that work for this city, this municipality, this area? And then people are dumbfounded. So there is a serious gap there.
Okay, thank you very much. Yeah.
Thank you.
That's an interesting move to policy.
Yeah.
What a
Indeed.
nice bridge. Felipe, I see some questions also coming to you. They're mainly about your about the theoretic frameworks that you use. Also suggesting that suggestions from other academics to look at transition management theories. Can you respond a bit?
Yeah, actually, I want to thank Otto, Waldo, Wendy, and Elma for their questions. I already read them, so I think I can group all of them in just one answer. I think all of them are completely right. The exercise I wanted to do is to look at the relation between circular built environment policy for its implementation as in academic literature. And of course, outside the academic discussions, there's a lot about policy for circular economy in construction, and for circular economy and the built environment itself. So the first question by Otto, I'm actually, my project is on policy coherence for the transition towards a circular built environment. So yeah, I'm doing a follow-up in case studies to see more than just the academic spectrum, to see what policies and policy instruments are actually used in the city level or national level for these transitions. I'm actually resorting to transition management framework. So thank you for that, Wendy. I completely agree with Waldo and to say that I wouldn't dare to say that there is nothing about policy for the circular built environment. And actually you can go back to sustainable built environment and Kiebert, for example, which is quite generic. This classification is from the 90s. So this is one of the things that actually, this is going to be a paper, but it's going to change, and I'm going to use something more attuned to what I actually want to look at. And the last question, if I'm not mistaken, was about the maturity of policy sciences and policy sciences, and actually how there's been more than 15 years of development, at least at the European level, and some other national levels as well. Probably, Belgium in the Netherlands also being like front runners in this sense. And actually, you can look at Amsterdam, for example, and see how the circular economy is now being part of something bigger. They are going for the donut economics, wherein and there the built environment is just one value chain to be observed and worked on. But also, like the ambitions are higher and higher, because you also need to look at how the built environment is connected to land use and the biochemical flows and pesticide use in agriculture. And at the same time, you need to look at water use. So the roof of the boundaries for research I always going bigger and bigger. So I really thank all of you for your comments and questions. I hope I've somehow answered.
Karen, you want to add some question?
No.
Maybe?
No, it's okay for me.
Yeah. Okay. Well, we also learned a lot about soil and sand. Maybe that's also one of the policy issues that emerge. So, Bram, moving to you. Let's see if I have the right question to scroll to the right questions again.
I think the questions were rather on the instrument, the second presentation.
Yeah.
So
how were the criteria for the instrument selected and validated, and how are they linked to different dimensions of circularity? A question by Mark van den Berg, the University of Twente.
Yes, well, thank you very much for this question, Mark. And I need to specify that validation, we still need to make multiple steps there. But regarding the selection, well, as explained, we conducted a literature study. And the answer models, the different answer models to the questions, are often related to the 10R model of circularity, or the 3-step based by means of prevention, making use of renewable sources, or making as efficient and effective use in a traditional sense, so with conventional materials. So the literature study was applied, and the basic principles of coming to circularity was applied in the answer models to multiple questions. However, regarding validation, as already honestly shared, we still need to make steps. That's for sure. So we still have to do quite some work on that point.
Maybe I have also one more question on that, because you subdivided the questions according to the materials, the equipment and the people. Could you give an example of a question regarding the people, just to get an idea of what kind of aspects you're covering there?
So, for example, the travel distance. So the people that are employed in the project, which distance do they need to travel, and which way of traveling do they apply? Mm-hmm. And as you can imagine, public transport to a new site as this is often not there. So maybe they can share a van to travel to a location, for example.
Mm-hmm. Okay, thank you.
Okay. Simon and maybe also Maarten, who is also present here, I think. There are also some questions about the Sirdax platform. So I repeat one of the questions by Elmar Willems. How do you actually estimate the qualities of the materials, the quantities and qualities of the materials in the built environment? And how do you assure the quality of the data that you gather? Please turn on your microphone also, because it's still turned off.
Of course, like I said in the chat, maybe it's not visible for everyone, but of course we get the drawings, we make manual inspections, you get 3D point cloud scanning, and of course we make use of statistics. That's very important for getting all the quantity right. The quality aspect is of course very important in reusing materials, because one of the essential elements why there's a low grade of reusing materials, that people want to use those second-hand materials, they don't know the quality of the materials. And that's a very common problem in reusing materials and circularity. That's called the lemons problem, clearly stated in the 1970s in economic theory. And of course, manual inspection will give us an answer to that, but it's also about organizing liability, and it's also about organizing transparency. And it's also organizing these aspects in transactions, so that if you put these materials on a marketplace, how does the other party know that those materials have a high quality? So the basic problem of nowadays the low-grade reusing of materials is the quality problem. So the question is very eminent: how do we assess the quality? From a building perspective, it's just, of course, it's looking at the materials, but for reusing, it's also about, can it be removed properly? Can it be done without waste? Can it be done in such a way that the demolition companies know how to assess those materials, how to use those materials, that the quality won't be reduced? And that, of course, will be done also to create liability on every aspect of the building. So how do I ensure the quality of materials in the buildings? Not only by inspection or looking at it, but it's also to organize a system in which those quality issues are assessed for many, many, many years. And that's also what we are elaborating on, is the use of blockchain technology. How can we get quality into a system in such a way that the liability aspects are organized on a long-term basis? And that's the ongoing research. That's also one of our projects in the UK now, because they're going to use this combined Sirdax and blockchain system for Grenfell Tower cases in order to ensure the quality of those plates on buildings for 100 years to go. And we're the primary provider of those systems for new railway stations to be built in the UK. And the one thing is, what do I say, that the circularity for building materials is primarily not in the building industry or research about buildings. It's primarily in law and economics. And in most of these discussions, I miss the aspect of law and economics. And once law and economics are not introduced into circularity regarding circularity of buildings, you won't get a circular system. And since research is about 99% is on the building side and not on the law and economics side, you got a mismatch, and also you get questions about how to deal with the quality. You don't solve that problem if you're not going to introduce other disciplines and crossing, of course, the boundaries of your own profession.
Thank you, Simon. It's almost
Sorry.
no worries. I just see the clock flipping to 10:30, so officially our session is open. I don't know if you get kicked out now or what happens, but maybe Karen and I can take 1 minute to try to round up the whole story of this very broad session. I'm happy to see that this interdisciplinarity has been well represented in your very broad perspectives, from design to policy to soil engineering, if I can call it that, and mapping and for building materials, and the plea for law and economics in that sense. So that would be my personal conclusion. Karen, maybe I invite you also to reflect a bit further.
I completely agree with you. I think it was the interesting part about this session, that it's so broad, but it also shows that we can learn from each other and that we can take up messages from each other to feed in our own research. And I think that's the strength of what I have seen today, because I think there are many learnings from other persons, or the reactions or the insights you got to take this home and integrate them in your own research. Yeah. So thank you all for your contributions. I enjoyed your presentations very much.
Well, thanks for sharing, and enjoy your stay at the conference. Presenters.
Thank you.
You too.
Thank you.
Okay. Thank you all.
Bye.
Bye
Have a
bye.
nice day.
Have a nice day.
Bye bye, you two guys.
Bye bye.
Karen, ben je er nog?
Ja, ik ben er nog eventjes. Ik zie dat er nog wel redelijk wat participanten zijn, denk ik. Of...
Nu begint het wat leeg te lopen, zie ik.
Ik heb het even opgezet, ja.
We moeten nog een klein woordje dadelijk ook doorgeven aan de chairs.
We moeten dat typen waarschijnlijk, hè? Of hoe gaan we dat anders bezorgen? Ja,
ja, in een kort tekstje.
Ja.
Wil je dat ik een voorzet doe of zo? Dat je dit doorstuurt per mail?
Dat is goed. Ik denk wat je gezegd hebt, is eigenlijk wel perfect voor mij. Het was een heel breed veld, hè? Dus, ik vond de ene zelf al interessanter dan de andere, maar dat is logisch natuurlijk. Als het, sommige bleven heel vaag, vond ik nog. Een beetje jammer dat we zo te weinig in de diepte nog kunnen gaan, maar dat is kort, 10 minuten. Je kunt niet veel. Het is echt gewoon een idee geven wat je doet. Hè. Veel meer gebeurt er eigenlijk niet. Maar ik denk dat goede feedbacks waren van de audience ook, dus dat is wel fijn om te zien.
Ja. Oké.
Weet je hoeveel participanten er in totaal waren? Want dat kunnen we misschien ook nog meegeven.
Er waren, dat wisselde, maar er waren meestal rond de 25 mensen met sprekers.
Ja. Misschien kunnen we dat ook vermelden, dat er een 25-tal deelnemers of zo waren.
Ja. Dat is goed.
Oké, super.
Ik stuur dat naar jou en dan kun je dan nog over de redactie voeren en dan sturen we het door.
Ja, perfect. Dankjewel.
Okay, ja.
Merci.
Bedankt, hè.
Dag.
Dag.